Your generator runs out of fuel at 2 a.m. Your battery bank dies at 4. You never counted the watts because you thought you had enough power. You were wrong. Every watt you burn is a watt you do not have later. Energy in a blackout is not infinite. It is arithmetic. You add the loads. You subtract the supply. When the answer is negative, you sit in the dark. Most people guess their power budget. They plug in everything. They hope the generator holds. It does not. The math does not care about hope. You need 3 numbers. Running, watts for continuous draw. Surge, watts for startup spike. Runtime hours for total consumption. Miss one and your plan fails in the first 60 minutes. Here is the science. Watts measure rate. A 60-watt bulb burns 60 watts every hour it runs. Watt-hours measure total energy. Run that bulb for 10 hours, and you spend 600 watt-hours. Your generator or battery has a fixed watt-hour capacity. Exceed it, and you go dark. Surge current is the spike when motors start. Your fridge pulls 150 watts running. It pulls 600 watts for 2 seconds at startup. If your inverter cannot handle the surge, the fridge never starts and your food rots. Phantom loads are devices that pull power even when off. Your television, your modem, your microwave clock. 5 watts here, 10 watts there. Over 24 hours, phantom loads steal 200 watt-hours you did not budget. That is 200 watt-hours you needed for light or communication. These 3 mechanisms kill every amateur energy plan. You will learn to measure, to cut, to rotate. You will learn what you actually need versus what you want. You will learn that most of your house is optional. Method 1. Critical survival baseline. This is the minimum to stay alive and informed for 72 hours. No comfort, no convenience, pure survival. You need 3 systems. Refrigeration to prevent food loss. Light to navigate safely. Communication to monitor emergency information. Here is why it works. The average U.S. household uses 30 kilowatt-hours per day. That is 1,250 watts continuous. You cannot sustain that on portable power, but critical survival is 300 to 500 watts continuous. You can run that on a mid-size battery bank or a 2,000-watt generator for hours per day. Calculate your fridge first. Check the nameplate on the back or inside the door. Look for running watts or amps. If you see amps, multiply by 120 volts. A typical fridge is 150 watts running, 600 watt surge. It cycles roughly 8 minutes per hour. Actual consumption is 20 watts average if you do not open the door. Do not open the door. Every time you open it, the compressor runs longer to recover. 1 peak costs you 10 minutes of runtime. 5 peaks an hour doubles your fridge power budget. Next, calculate light. 1 5-watt LED bulb gives you enough light to move through a room. 3 bulbs give you task light for cooking and sanitation. Budget 20 watts continuous for light, not 200. 20. Use flashlights and headlamps when moving. Use fixed bulbs only where you work. Now communication. Your phone charger pulls 5 watts. Your battery radio pulls 2 watts. Your laptop pulls 45 watts. Budget 60 watts for comms and information. Charge devices in rotation. Do not charge 3 things at once. Add it up. 20 watts fridge, 20 watts light, 60 watts comms. Total 100 watts continuous. Over 24 hours. That is 2,400 watt-hours. A 1,500 watt-hour battery bank runs it for 15 hours. A 2,000-watt inverter generator running 6 hours per day at 1/4 load refills the bank and keeps you live. Pro tip. Write your critical load list on a card and tape it to your generator or battery. When the power fails, you will not think clearly. The card thinks for you. Safety line. Never run a generator indoors or in a garage, even with the door open. Carbon monoxide is silent, and it kills faster than cold or hunger. Method 2. Medical and accessibility loads. If someone in your home needs electrically powered medical devices, this is your first priority. Not your fridge, not your phone. Life support comes first. Here is why it works. Medical devices have known watt ratings and known runtimes. You can calculate exactly how much power they consume and build your entire energy plan around that number. Everything else flexes. Medical does not. List every powered medical device. CPAP. Machines, oxygen concentrators, nebulizers, medication fridges, mobility device chargers, communication devices for hearing or speech. Check each nameplate or manual for watts or amps. A typical CPAP pulls 30 to 60 watts depending on humidifier settings. An oxygen concentrator pulls 300 to 600 watts. A medication fridge pulls 50 watts average. Add the runtime. If the CPAP runs 8 hours per night, that is 480 watt-hours. If the concentrator runs 24 hours, that is 7,200 watt-hours minimum. That is a huge load. You need a generator or a very large battery bank. Now calculate your backup. If your primary power source fails, what is your secondary? If your generator runs out of fuel, do you have battery backup for the concentrator? If your battery dies, do you have medical oxygen tanks as a manual fallback? You need 2 layers minimum. 3 is better. Primary power, battery bridge, manual or non-electric alternative. Write the startup sequence. Which device turns on first? Which settings you reduce to conserve power? Oxygen concentrators often have lower flow settings. CPAP can run without the humidifier to cut watts in half. Know the compromise before you are forced to make it in the dark. Pro tip: test your medical devices on backup power during the day once per season. Find out now if your inverter creates electrical noise that interferes with the device. Find out now if the surge current trips your system. Safety line: never reduce medical device power or settings without direct guidance from the prescribing physician. Conserving watts is meaningless if it costs you health or life. Method 3. Heating and cooling. The math. Electric heat and electric cooling are energy monsters. A space heater pulls 1,500 watts. A window air conditioner pulls 1,200 watts. Run either one continuously, and you drain a battery bank in under 2 hours. Here is why most people fail. They try to heat or cool the whole house. That takes 10,000 watts or more. You do not have 10,000 watts. You have 2,000 watts if you are lucky. The mismatch is fatal. The physics is simple. Heat moves from warm to cold. The bigger the temperature difference and the bigger the space, the more watts you need. Cut the space. Cut the difference. Cut the watts. Choose one room. Insulate it. Seal it. Heat or cool only that space. A well-insulated 12 by 12 room needs 300 to 500 watts of heat to stay livable in winter. The same room needs 600 watts of cooling to stay survivable in summer if you add shade and ventilation. Here is the counterintuitive part. Electric resistance. Heat is 100% efficient, but it is still the worst option in a blackout. You get 1 watt of heat for every watt of electricity. That is a terrible trade when watts are your scarcest resource. Use combustion heat instead. Propane, wood, kerosene. You get 10 to 20 times more heat per dollar, and you do not drain your electrical budget. Your electrical budget keeps the fridge cold and the lights on. Let fuel handle the heat. If you must use electric heat, use it in pulses. Heat the room to 65 degrees Fahrenheit. Turn off the heater. Let the room coast down to 55 degrees. Heat it again. The average watt draw drops by half compared to continuous heating. For cooling, the priority is survival, not comfort. Wet your skin. Aim a fan at your body. Evaporation cools you without cooling the air. A 20-watt box fan and a damp shirt outperform a 1,000-watt air conditioner for personal cooling. The air conditioner cools the room. The fan and water cool you. You are the only thing that matters. Pro tip: thermal mass holds temperature. Heat bricks or water jugs on a propane stove and bring them into your insulated room. They radiate heat for hours without burning watts. In summer, freeze water jugs when you have power and use them as passive cooling when you do not. Safety line: any combustion heater produces carbon monoxide. Crack a window 1 inch minimum. Ventilation is not optional even if it costs you heat. Dead from gas is still dead. Method 4. Phantom load audit. Right now, before the power fails, you have devices pulling watts while doing nothing useful. They are stealing your future runtime. Here is why it works. Phantom loads are invisible until you measure them. Once you see the numbers, you unplug the waste. That frees up 10 to 20% of your energy budget for things that matter. You need a cheap watt meter. Plug it into the wall. Plug your device into the meter. Read the watts. If the device is off and the meter shows anything above 0, that is a phantom load. Walk through your house. Test everything. Television, cable box, microwave, coffee maker, laptop charger, phone charger, printer, router, modem, audio gear, anything with a remote control or a clock or a wall wart transformer. Write down every device and its phantom watts. Add them up. Multiply by 24 hours. That total is watt hours. You lose every single day to nothing. A cable box pulls 30 watts even when off. Over 24 hours. That is 720 watt hours. That is enough to run your fridge for 36 hours. The box does nothing. The fridge saves $50 of food. You choose. Unplug everything you do not need in a blackout. Right now, not later. Pull the plug on the cable box, the smart speaker, the decorative lights, the second television. When the grid drops, those devices stay dark and you keep the watts. For devices you do need, use a power strip with a switch. Plug your router and modem into the strip. When you do not need internet, flip the switch. Phantom draw goes to 0. Pro tip: laptop and tool battery chargers pull 0 watts when no battery is attached. Phone chargers pull 1 to 2 watts even with no phone. Unplug phone chargers. Leave tool chargers plugged in. It is a tiny thing, but tiny things add up over 72 hours. Safety line: unplug devices during a blackout to prevent damage from power surges when the grid comes back. Surge protection only works if the device was off or unplugged before the surge. Method 5. Rotation and stagger strategy. You do not run all loads at the same time. You rotate them. One device on, another off. Stagger the peaks. Flatten the curve. Here is why it works. Peak load determines your generator or inverter size. If you run the fridge, the microwave, the lights, and the phone charger all at once, your peak is 1,800 watts. You need a 2,000 watt inverter, but if you stagger those loads, your peak is 300 watts. You need a 500 watt inverter. Smaller inverter means smaller battery weight, lower cost. Make a rotation schedule. Write it down. Tape it next to your critical load card. Hour 0 to hour 1. Fridge runs. Lights off. Phones charging. Total 170 watts. Hour 1 to hour 2. Fridge off. Lights on. Laptop charging. Total 65 watts. Hour 2 to hour 3. Fridge runs. Microwave heats 1 meal. Lights on. Total 1,300 watts for 2 minutes. Then back to 170. You never hit peak on everything simultaneously. Your average load stays under 200 watts. Your battery lasts 5 times longer. Stagger surge events. Do not start the fridge and the microwave at the same moment. The combined surge will trip your inverter. Start the fridge. Wait 30 seconds. Start the microwave. Each surge happens alone. Your inverter survives. Teach everyone in your house the rotation. If someone plugs in a hairdryer while the microwave runs, your system shuts down and everything resets. The reset costs you stored food, temperature, and device wear. Discipline saves watts. Pro tip: use a kitchen timer. Set it for 30 minutes. When it rings, switch loads. The timer enforces the rotation so you do not forget and leave something running. Safety line: if your inverter or generator overloads and shuts down, do not restart it immediately. Unplug every device. Wait 60 seconds. Restart the inverter. Add one load at a time. Rapid cycling damages electronics. Method 6. Manual fallback and 0-watt alternatives. Every watt you do not spend is a watt you still have. For every electrical device, there is a manual alternative that costs 0 watts. You need to know it, own it, and practice it before the lights go out. Here is why it works. Electrical devices trade your effort for convenience. In a blackout, convenience is a luxury you cannot afford. Effort is free. Watts are not. Lighting. A 5-watt LED bulb runs for 1 hour on 5 watt hours. A candle or an oil lamp produces the same light for 0 watt-hours. The trade is fire risk and air quality. Manage the risk. Save the watts for something only electricity can do. Refrigeration. Your fridge uses 2250 watt-hours per day if you manage it well. A cooler with ice uses 0 watt-hours. Freeze gallon jugs of water while you have grid power. When the power drops, move critical food to the cooler with the ice jugs. The ice keeps food safe for 3 to 5 days depending on outside temperature and how often you open it. Do not open it. Your fridge becomes a backup. Your cooler becomes primary. Cooking. An electric hot plate pulls 1500 watts. A propane camp stove produces the same heat for 0 watts from your electrical budget. You trade electrical energy for chemical energy. Chemical energy is cheaper, denser, and easier to store. Water. An electric pump pulls for 100 watts. A manual siphon or a gravity filter pulls 0 watts. If you have water stored above your use point, gravity does the work. Entertainment and morale. A television pulls 150 watts. A book pulls 0 watts. A battery radio pulls 2 watts and gives you news and weather. Choose the radio over the television. The television does not tell you when the roads reopen or when the grid comes back. Write a 0-watt list. For every electrical device you depend on, not the manual alternative. Test each alternative once. Find out now that your hand can opener is dull or your oil lamp needs a new wick. Fix it now. Pro tip. Trash becomes resource. Cardboard is insulation and fire starter. Plastic bottles are water storage and ice molds. Aluminum cans are reflectors to boost candlelight. Before you throw anything out, ask if it saves you watts in a blackout. Safety line. Candles and oil lamps produce carbon monoxide in small amounts and open flame is a fire risk. Never leave them unattended. Never use them near bedding or curtains. Keep a working fire extinguisher within 10 feet. The counterintuitive truth about generators. Everyone thinks a bigger generator is better. More watts, more capacity, more safety margin. That is wrong. Here is why. Generators are most efficient at 50 to 75% load. Run a 4000-watt generator at 500 watts, and you burn fuel at 20% efficiency. You waste 80% of every gallon. Your fuel disappears and you have nothing to show for it. A small generator matched to your actual load will run longer on the same fuel. A 2000-watt inverter generator at 75% load burns roughly 0.15 gallons per hour. That is 16 hours per gallon at 1500 watts. The same generator at 20% load burns 0.08 gallons per hour, but only delivers for 100 watts. You get fewer watts per gallon. Right size your generator to your real load, not your imagined load. If your critical baseline is 300 watts and your peak stagger load is 1000 watts, a 1000 to 2000 watt generator is correct. A 4000 watt generator is waste. The second counterintuitive truth is runtime versus capacity. People buy huge battery banks and run out of power in 12 hours. They never calculated watt hours. They only looked at amp hours and volts. A 12-volt battery rated at 100 amp hours holds 1200 watt hours at perfect efficiency. Real efficiency is 85%. Real capacity is 1000 watt hours. If you pull 200 watts continuous, you have 5 hours of runtime, not 12. Double the battery cost to double the runtime, or cut your loads in half and double your runtime for free. Cutting loads is faster and cheaper than buying batteries. The third counterintuitive truth is solar. People think solar panels generate power in a blackout. They do not unless you have an off-grid or hybrid inverter. Standard grid tie solar shuts down when the grid drops. It is a safety feature to protect line workers. Your panels sit there in full sun producing 0 watts while you sit in the dark. If you have solar, check your inverter type now. If it is grid tie only, your solar is decorative during a blackout. You need a battery and a hybrid inverter or a separate off-grid charge controller to harvest that energy. Know what you have. Know what it actually does. Assumptions kill your energy budget faster than any load. Now you have the methods. You know how to calculate critical loads. You know how to audit and eliminate waste. You know how to rotate and stagger. You know the manual fallbacks. You know the counterintuitive truths that separate real capacity from fantasy. Here is what you do next. Walk through your house with a notebook. List every device you think you need in a blackout. Find the watt rating. Add them up. Compare that number to your generator or battery capacity. If the number is bigger than your capacity, start cutting until the math works. Test your plan during the day. Shut off your main breaker. Run your house on your backup power for 4 hours. Find out what fails. Find out what you forgot. Find out that your internet router needs a power brick you did not budget for, or your sump pump pull is 3 times what you thought. Fix it now while the stakes are low and the grid is still up. Every mistake you make in practice is a mistake you do not make when it counts. Store fuel safely and rotate it every 6 months. Gasoline goes stale. Propane does not. Diesel lasts longer than gas, but still needs stabilizer. Know your fuel and treat it right, or it will not be there when you need it. Label everything. Label your generator output watts. Label your battery capacity in watt hours. Label your critical loads. Label your rotation schedule. When you are cold and tired, and the power has been out for 36 hours, you will not do math in your head. The labels do it for you. Keep your expectations low and your calculations honest. You will not live like the grid is up. You will live like the grid is down, and you have a plan. The plan is not comfort. The plan is survival. With enough light to see, enough cold to save food, and enough power to know when it ends. That is the budget. That is the discipline. That is the difference between 3 days of function and 3 hours of chaos. You count the watts. You cut the waste. You rotate the loads. You fall back to manual when the numbers stop working. The math does not care how you feel about it. The math is the only thing that matters. Method beats magic. Discipline beats disaster. You do the work now, or you sit in the dark later. Count the watts. Cut the load. Survive the night.